This meeting is being recorded.
Just like we saw with sections 9.8 and 9.9, sections 9.10 and 9.11 are also on the shorter end, and I will do this video of both sections 9.10 and 9.11 together because of that. So let's take a look here at an alkylation of terminal alkynes. So we see down here we have a terminal alkyne. So we have a hydrogen on one end and then an R group on the other. So we can form an alkynide ion, this thing over here. So we deprotonate using our base here, and this alkynide ion forms, and these are good nucleophiles, right? They have a lone pair and a negative formal charge on the carbon. So we can actually see SN2 substitution reactions occur with alkyl halides. So think back to chapter 7 with substitution and elimination reactions, and we'll look at a couple things that hopefully you remember from that chapter. So here we have the R group. Right, so this is our alkyl group here. That's going to be alkylating our alkynide. And then we have, so the lone pair here grabs that R group, and then these electrons are transferred to this X, so we have our loss of leaving group, if you remember, in this concerted mechanism with SN2 reactions. And then we have formation of this new carbon-carbon bond. So effectively, we have added that R group onto that terminal alkyne. So as I mentioned, this is an SN2 substitution. So methyl or primary halides will work the best. And then when we have these secondary or tertiary halides, if you recall from, again, chapter 7, E2 elimination would be the dominant mechanism that we see, not substitution. So we want substitution. So we would then use methyl or primary. So that's what we see down here with step 2. So first we have our deprotonation from our base, right? So that grabs that there. We have that alkynide ion that forms, and then this new CC double bond with that alkyl group that I just circled being added. So this is the bond actually here that we would see. And specifically with acetylene, we can do 2 successive and different alkylations, one on each side, right? So we can remove this proton, or the way that they have it here, rather, they remove this proton first, and then we have installed this R group here. And then you can do that again. So let's take a look at this example here. And we have this double alkylation of acetylene. And notice that we're told that it must be done stepwise. So that means that, we have one step here collectively between this use of base and then this alkylation. So this would be a step 1. We can't add to both sides at one time. So then this would be step 2, where we add the methyl substituent, and in the first step we added an ethyl. So you can see our final product over here, the 2 different R groups that we've added. And a fun fact about what this can do is you can create a complex target molecule, so a molecule that you want to create, by building your carbon skeleton and then going back and converting functional groups. So where you have a double bond, you might want a triple bond, or you might want only single bonds, or you might want to add different functional groups. We'll see later on. But here we can see conversion between triple bonds to double bonds or single bonds. What we have is, if we start with an alkyne in this synthesis strategy, so I should note that we have transitioned on this slide to section 9.11. And we can see here in this top mechanism pathway that with a platinum catalyst and molecular hydrogen, we could fully convert an alkyne to all single bonds and form an alkane product. Then we have this pathway here by using either a poisoned catalyst, if you remember that term. Windler's catalyst is one, or a metal dissolved down here with sodium in ammonia. We can create an alkene as our product. And then last, we have taking an alkene and reducing that one more time, adding hydrogen across the double bond to form an alkene. So you can do step-by-step conversion of a triple bond to double, then to single, or you can convert it in one step. So another synthesis strategy, what if we wanted to functionalize something? What if we wanted to move our double or triple bonds? We can do so. We can halogenate an alkene. So that's what we see here, our alkene. And we add this molecular bromine here. So that's the halogen that we've added in this halogenation step. And you see that there's two bromines now added. And then we perform an elimination here in our second step and follow that with H2O with water, and we then can yield, after two successive eliminations, a triple bond, an alkyne. So we can interconvert single, double, and triple bonds. This slide here shows ways to go back and forth. Notice that we'll see this coming up in the next chapter. They don't want to reveal it here. But what you should note for the reactions of alkynes, this slide here has a summary of every reaction that we looked at. You should notice the differences and the similarities to alkenes. And then this last slide here is again a summary slide that lists all the mechanisms and all the transformations that you may see in this chapter.